So we're going to look at again the graph of irrational functions, and this is in particular with the parent function f of x is equal to 1 over x. So I will have some values to choose. I'll get -2, -1, 0, +1, and then 2. So in this function, if I will plug in -2 into the x, I will get what value? Yes, it is -1/2. Then if I will plug in -1 into this, so -1 over, or 1 over -1 is -1. But what happened if I plug in 0? Yeah, that is correct. You will get undefined. If you're doing it in the calculator, it will say error. And that value that's making this x undefined, that is the what we called vertical asymptote. So vertical asymptote is when your rational function will give you undefined value. The value that will make this function not defined. And that would be at x equals to 0. So it's like when we grab it here, there's no value that's going to be crossing this x is equal to 0. It is y-axis, but as an equation, it is x is equal to 0. And then, so we're going back to this value now. So 1 over 1 is 1. And then 1 over 2 is 1/2. So what we're going to be doing is plot these points now to see again the graph of the parent function. So for -2, I have a -1/2. For -1, it's -1. And when I get to 0, no value will make it true. It's undefined. Then we'll do this 1. The value is 1 for the y. And then at 2, it is 1/2. Then if I'm going to have a 3 here, that means I will have 1/3. If it's an x equals to 4, I'm going to have 1/4. So as I keep on having x values greater and greater, this part of the graph is just approaching this x-axis. And that part is what we call horizontal asymptote. And that happens when your value of x, as it gets larger and larger, it is approaching a certain value, a constant value, which in this case, it is y equals to 0. So I will connect this approaching 0 here, and on this other side, closing 0, getting closer to 0 from the right side, it's just approaching infinity. And then on this side, the same thing. As x gets smaller and smaller, it's approaching 0. And as the x value gets closer and closer to 0, coming from the left side, the y value is getting smaller. It is approaching negative infinity. So when we talk about key features here, so let's start with set up domain, and that would be, that is correct. We have all real numbers except x is 0. And then for our set of range, that would also be all set of real numbers except you have y cannot be 0. Now, do we have a what we call intercept here? As you could see, the parent function did not intersect the x nor the y-axis, so there's no x nor y intercepts. But we can also say here that as the x approaches negative infinity, like for the end behavior, so I'm going to include the end behavior. As x approaches negative infinity, what is happening to the y? Yes, y is approaching 0. It's not going to be 0 because we don't have an x-intercept here. It's just getting closer and closer to 0. And then on the other side, as x approaches positive infinity, the y is also approaching 0. I will also introduce to you this x value approaching 0 from the left side, and that is the end behavior coming from the left side getting closer to 0. It's not gonna hit 0 because there is no y-intercept as well, so we're just getting closer and closer to 0 coming from the left side. And what's happening to the y? Y is approaching negative infinity. And then on the other side of 0, so 0 approaching from the right side, we call that as x approaching 0 from the right side, the y value is getting larger and larger. So these are additional information we have for the key features of the parent function. All right. What I want to do next here is using this graph of the parent function, which is f of x equals to 1 over x. I want to use this function graph to get the graph of another function, which is g of x. I'm going to call it g of x over 1 over x minus 1. So based on what we did in the past, this x minus 1 or the minus 1 is grouped with the x. So that's going to cause what kind of translation? Yes, it is a horizontal translation of what? It is 1 unit to the right. So since I already have these parent functions, to get the graph for these new functions, all the points that I have here, I will just translate 1 unit to the right. So this first visible point that I have, I will just move it 1 to the right. So this is the new location. Same thing right here, 1 to the right. And what's also happening here, this vertical asymptote will also move 1 unit to the right. So let me mark that new location of the vertical asymptote. So I get this as my new vertical asymptote. Okay, let me use a different color instead of that because my points are already green. Okay, let me redo this. So this is the location of my new vertical asymptote, which as an equation, it is now x is equal to 1. Earlier from the parent functions, we have x is equal to 0. So notice what happened with the vertical asymptotes too. Okay, and then let me continue plotting the points. So doing the same thing here, 1 unit to the right. So I got a new point here, and also with this one, 1 unit to the right. Okay, so the same thing is happening as I get closer and closer to 1 from the left side. This one is going to infinity, or I should say negative infinity, this end. And then on my left end, coming to, or as x gets be smaller and smaller, it will now approaching negative, or as x approaches negative infinity, the y is approaching 0. Then coming from the right side, as x getting closer and closer to 1, the y value is approaching positive infinity. But as x gets bigger, the y is approaching 0 also. Okay? So it's the same thing that we have done in the past, that when you have a translation, like in this case, it is with the x, the direction of the translation is horizontal. Then if I'm going to have something like, let me call it k of x, and I will put it as 1 over x, and then into this part of the parent functions 1 over x, I will do minus 1. Okay, it's no longer growth with x. This time it is subtracted from the actual parent function. So what kind of transformations will happen? That is correct. You're gonna have to shift it 1 unit down. So all the points from the parent functions, you're gonna shift it down. What is happening now is this will intersect the x-axis, so we can get the x-intercept. And on this first g of x, you could see that we now have the y-intercept. Okay, so for the end behavior here, for this g of x, some of the features have changed because we don't have these key features anymore for the domain and range for this part. What would be the domain for this? That is correct. Instead of x is not 0, this one you have x cannot be 1, because when you plug in 1 here, that will be undefined. But did we keep the same range? Okay, that is correct. We kept the range. Y cannot be 0, as you could see here. Okay, but on this one, do you think that we are keeping the same key features? So that's something that I'm going to leave out there for you to think about.